So we have 7.3. Okay, we're going to talk about trig substitution. Okay, trig substitution. And this is for Math 110B. This is page 1. Right. So in this section, we're going to deal with this type of integral. So when the integral over here involve this square root of, okay, let's just put the square root over here. 3 types of square root, okay? So what are the 3 types of square root? Okay, square root of a squared minus x squared, a squared plus x squared, or x squared minus a squared over here. Okay, where a is a positive constant. Okay, so the a over here will be a positive constant. Okay, now how do we do this? So I'm also going to give you a trick that I have to help you to remember how to deal with this type of integral. Okay, so I have my own trick. Okay. Okay. Now, do you guys recall this identity? Okay, so what is this identity? Identity. Okay. We have 1 minus sine square theta that's equal to cosine square theta, right? Okay, so think about this identity, okay? Now, if you can remember this identity, that is going to help you to deal with this integral of this type that involve the square root of a squared minus x squared. Okay, so when you have this integral over here involve square root of a squared minus x squared, think about this identity over here. Okay, so when this is in this integral over here, so you kind of wish that the inside the square root will be a perfect square, right? If you take the square root of a perfect square, then the perfect square and the square root are going to cancel, and then you can get rid of the square root right there, right? Okay. So the point over here is, how can I get this inside here to be a perfect square? Okay. So now looking at this identity, that will give us some idea. Okay. So think about this a here corresponding to this 1, and this x squared here corresponding to this sine square over here. Okay. So if I want to get rid of I try to get rid of this square root right here. Okay. Then we use something called trig-sub. Okay. So the thing that we're going to talk about today is called trig-sub. Okay. It's called trig-sub. Yes. Okay. Now you're going to let x to be equal to, okay, looking at this, we'll have something involve the sine theta, okay? So correspond to this. So think about this correspond to this a square, and then this one correspond to the x square. So you let x equal to a times sine theta. Okay, let's try this and see what happens. Okay. So if I let x equal this, where theta over here is actually between negative power 2 to power 2. That way, x is going to go from negative a to positive a, which is within the domain for this function, right? Okay, click on this. Okay, if I do this trig-sub over here, tell me what this become. This is going to become square root of, now we have this a squared, minus the x over here is a times sine theta, okay? So this is going to be a square sine theta square, okay? Well, we could take out this common factor, a square, right? Okay. And then we have 1 minus sine square theta, okay? And this is going to be square root of a square times sine square theta. You see what's happening over here? This, oh, I'm sorry. Just see, you will pay attention, okay? 1 minus sine square theta is equal to what? What does it equal to?
Cosine squared theta.
That's equal cosine square theta. Okay, so we're using this identity over here. Okay, so that is cosine square theta. Okay, so now over here, because a is a positive constant, when you take the square root of a squared, then this one here, it will be, the a will be out, right? So a is out. And you take the square root of cosine square over here, that will be equal to just cosine theta. Because cosine theta is non-negative over here, okay? Why is that non-negative? Because you see this theta over here is between negative power 2 to power 2, okay? And at this, when theta is between this one and this one, cosine theta is positive. So you don't need to put an absolute value over here, okay? So when I do this trig-sub over here, okay, I let x to be a times sine theta. At the end, I was able to get rid of the square root and somehow get this expression without a square root, okay? So the trig-sub is going to have this, so can do this trick, okay? So have this magic, okay? Okay, so let me make a note over here, because a is greater than 0 and also cosine theta is greater than or equal to 0, okay? Okay, so when you have integrand that is of this form, think about using this trig-sub. Let x to be a times sine theta. And then at the end, you see that it's become a times cosine theta. And you see this correspondent over here, cosine theta, okay, like that. Okay, now let's deal with the other case. Okay. Okay. Okay, now the trig identity. 1 plus tangent square is equal to secant square. Okay. Now, if you can remember this identity, then you know how to deal with this, the type of integral that involves this square root of a squared plus x squared. Okay. Now, somehow we want to get rid of the square root because then when we integrate it will be easier, right? So I'm going to do a trig-sub. Okay. So what do you think I'm going to let x to be? Looking at this identity over here.
Tangent squared.
Almost. Okay, try it one more time. So think about this corresponding to this a square, right? This corresponding to the x squared there. So
1 plus tangent squared. Really?
let x go to the, look at this example here, up here, okay? So you need to have this x to be a times tangent theta, okay? Right, so that will have a times tangent theta, okay? Where theta is going to be between negative power 2 to power 2, okay? Now by doing this, what do you think this is going to become? Square root of a squared plus a squared tangent square theta, right? Which is going to be what? Square root of a squared times what? 1 plus tangent
Secant
square.
square.
Yeah, it's secant square, okay? Let's get to the next one, okay? So that will a squared times secant square theta, right? Okay, and now when you do that, that will going to become when you take the square root of that, then you're going to get a times secant theta, right? So by using this trig-sub over here, okay, I was able to express this by a times secant theta, okay? So the square root is, we got rid of the square root there, okay? Okay, so when you deal with this type of, when the integral is of this form, think about this identity like this. So you will have x to be a times tangent theta. And the result over here, you will have a times secant theta. Just you see the secant theta over here, okay? Okay, now I can change this identity around, right? I can have secant square minus 1 equal to tangent square, okay? So I will have secant square minus 1 equal to tangent square, okay, equal to the square of tangent theta, okay. Now, if I put it this way, okay, then I'm going to ask you guys, how am I going to deal with this when the integral is of this form, x squared minus a squared? I'm going to use trig-sub, okay. So what I'm going to let x to be over here?
A secant theta.
Yes, got it, okay. So we let x to be a secant theta, okay. You see this corresponding to this x squared, this corresponding to the a squared, right? Okay, and where this theta is going to be between 0 and power 2 or pi and 3 pi over 2. So that way it's going to take on, so the x will take on every value in the domain for this function, okay? Okay, now if I do this type of trig-sub, what do you think this is going to become? Okay, what do you think it's going to become? It's going to become a times what? Okay, you guys can try it on paper, then you can do it the long way, okay?
A times tangent.
Yes, you got it, okay? So it's a times tangent theta, okay? So think about the trig identity this way, okay? So we are able to deal with integral that are of either this one, and this one. Think about the corresponding trig identity here over here. Okay. 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 Now let's do one example. Okay. So I'm going to do this example. Okay. So this one here involved the form had the square root of 9 minus x squared. Okay. So that is going to, so that we might as to use trig-sub. Okay. Because this one looks like it has the square root of 3 squared minus x squared. So I'm going to use trig-sub. So what I'm going to let x equal to? So
3 sine theta?
Yes, 3 sine theta, right? Okay. So we have 3 sine theta. And then what does this become?
Uh, 3 cosine theta?
3 cosine theta. Okay, so then this becomes 3 cosine theta. Okay, all right. Now, some of you didn't answer that. Maybe you're not sure what to do. Okay, so remember when you have this, try to think about this identity. This corresponds to the 1, and that corresponding to the square. Okay, you think about, you have this 1 minus 1 square equal to what square over here? Okay. So you want to get a square at the end, right? So you put it this way. There's a 3 square corresponding to the 1, and then you have a square here. You want to make this whole thing inside the square root to be a perfect square. So you think about what will be the identity, right? So now you can fill in the blank. You say, okay, maybe this should be sine theta, and then this will be cosine theta. Now, some of you might say, what about if I let this to be cosine theta, that's sine theta? That will also work, but I think this will be a little bit easier. Let x to be 3 sine theta, okay? So over here, you have this sine theta, and then this will be cosine theta. Okay, that's how you put this. Okay. Okay. All right. So now if x equal to 3 times sine theta, remember the data over here. You don't need to put down this all the time. Just remember this is power 2. Okay. So what does dx equal to? If x equal to this, what does dx equal to? Dx will be equal to 3 times what? What's the derivative of sine theta with respect to theta? Cosine theta, right? Okay, and then what? Don't forget to put a d theta over here. Okay, so we get dx is 3 cosine theta d theta. The derivative sine here is cosine, okay, and then put a d theta at the end. Okay. Now let's go back to this integral and see what's happening over here. Okay. So that will become this integral. Okay. Now up here in the numerator, and this square root over here actually becomes 3 times cosine theta, right? Okay. So we have this 3 cosine theta over here. Okay. What about this x squared over here? What does it become? Well, we have x here is equal to 3 sine theta, right? So you just copy this. So substitute 3 sine theta into x. So you have this 3 sine theta, that's x. And then you square this. What about this dx over here? What does dx here become?
3 cosine theta d theta.
Yes, you got it. Okay. So the dx over here, it is going to be 3 cosine theta d theta. Okay, so that becomes this. Are you guys good? Is it too fast for you guys? All right. So the next step here, we just need to simplify this. Okay. So simplifying this, what do we get? We're going to get cosine square theta over sine square theta, right? Okay, and then d theta over here. Because see, the 3 squared is 9, so you cancel with this 3 times 3. So then 3 over here, they all cancel out. Okay. Now, cosine over sine. What's cosine over sine? Cosine over sine, it is what?
Tangent.
Cotangent. Yeah, it's cotangent.
Sorry.
It's a cotangent. Okay, and this is a square over here, so it's a square. So it is cotangent square. Okay. Now someone will say, oh, what is the antiderivative of cotangent square? We don't have a formula, right? But we do know cotangent is related to cosecant. Remember this identity, okay? The trig identity, okay? You have 1 plus cotangent square is equal to cosecant square. Just like 1 plus tangent square equal to secant square. And this one will be similar, okay? So this is another trig identity. This is not used very frequently, but it's one of the identity, okay? So looking at this, I'm thinking maybe I should relate this with cosecant square because we know the antiderivative for cosecant square of theta, right? So let's relate this with cosecant square, okay? So this will become cosecant square theta minus 1, then d theta, right? Okay, that's good. Are you guys good?
Yeah.
Okay, so now let's find antiderivative cosecant square. Do you guys remember what's antiderivative cosecant square? Probably don't remember. Okay, let's be,
Negative cotangent.
yes, negative cotangent, okay? We call that the derivative for cotangent theta. It is equal to negative cosecant square theta, right? So antiderivative of cosecant square will be negative cotangent theta. So over here, this will be negative cotangent theta, okay? So you got this, okay? That's how you got this. Okay, And then what's the answer to -1 with respect to data?
Negative.
Data.
Yeah, so negative data. Okay, so that's negative data. Don't forget to add the constant. So press C. Now finally, we're not done because remember that was an integral with respect to what? With respect to x, right? Okay, so we want to finally return back to x. So to return back to x, I'm going to give you a trick also. Okay, so use this kind of trick. Okay, it's a Y triangle trick. Okay. Y triangle here. Okay. So what do we know about what kind of trig-sub did we use? The trig-sub that we used before was x equal to 3 sine theta, right? So that was a trig-sub we used in the beginning. Okay. So which means that sine of theta equal to what? X over 3, right? Okay. So sine theta here will be equal to x divided by 3. Okay. So this is the angle. Okay. Sine is opposite over hypotenuse. So if I label this angle over here theta, then the corresponding side I can label that. If the corresponding side is x, then the hypotenuse over here will be 3. Then what will be this adjacent side of this angle? This one. By the Pythagorean thing, what will be this? Square root of
3 square minus x square.
3 square minus x square, right? Yeah. So which is going to be 3 square minus x square, which is 9 minus x square by Pythagorean theorem. Okay. Okay. Now once you get this y triangle here, you're going to deal. You're able to deal with all of this over here. Okay. All right. So this is data. Okay. So now we have this cotangent data. Cotangent is what? Adjacent over hypotenuse, right? Do you guys agree? Yes. Okay. So now you have this negative sign. Now we have this adjacent side for the data over here. It is what? It's going to be this one over here, right? Okay. So that will be square root of 9 minus x squared. Remember, this is the adjacent. This is the adjacent side, right? Okay. So the adjacent side of the data is this, and then over the hypotenuse over here will be 3. So over 3. So this will be cotangent data, right? Okay. Let me maybe write it down a little bit. Okay. So over here, remember SOHCAHTOA, right? SOHCAHTOA. Okay. And we have this. You don't need all this. Just focus on cotangent. Okay. So cotangent data is equal to adjacent side over. No, I make a mistake. Can you guys what
Yeah.
mistake?
Is it over x, not over
Yeah.
3?
Yes.
Yeah.
The cotangent over here, it is going to be cotangent is adjacent over
Opposite.
opposite. Yes. Good job. Okay. So you are paying attention. So I'm just checking if you're paying attention or not. Okay. All right. Thank you, Alexi. Okay. Okay. So cotangent. Okay, let's write it down. Okay. Cotangent of data is equal to adjacent over opposite. Okay. Opposite over here. Okay. Now the adjacent side of this data here, it is square root of 9 minus x squared. And the opposite side of this angle here, it is, oh, sorry. Okay. The opposite side of this angle here is x. So it's over x. So cotangent data over here, it is this adjacent over opposite. So you have this. So that's why I put it over here. Okay, so over x. Okay. Okay, so that take care of this cotangent data. What about data? If I have sine data is equal to x over 3, and remember data is between negative power 2 to power 2. If we have that, then what can we say about data? Data will be equal to what? Will be equal to the inverse. Okay, will be equal to the inverse of x over 3, inverse sine of x over 3. Okay, so that will be equal to the, do you guys remember the inverse sine function, right? So we did the review very in the semester. So inverse sine of this x over 3. Okay, because data is between negative power 2 to power 2. So sine data equal this, data will be equal to the inverse sine of x over 3. So that will take care of this data over here. Okay, so let's put it back. So this is minus inverse sine of x over 3. Finally, adding that constant. So the trick to deal with this is use this right triangle over here to take care of this cotangent data, and take care of the data over here by taking the inverse of this x over 3 right here to put it here, and then don't forget the constant. Okay, so the final answer over here will be this. Okay, are you guys good? Okay. Some of you might have question about this, right? I'm going to give you a quick review on this, okay? We call that about inverse sine, okay? If you have a data is in negative power 2 to power 2, okay? Say sine of data is equal to 1/2. Now this is going to imply that data equal to what? Data will be equal to the inverse sine of 1/2. So basically that represents the angle. So this
Pi over 6.
yes, you got it. Yeah, so think about the angle in here. So then sine of that equal 1/2, and you just answer that it is pi over 6, right? Yeah, sine of pi over 6 is equal to 1/2, and pi over 6 is in here. So data is equal inverse sine of 1/2, which is pi over 6. Okay, so this is so that's one example. Okay, maybe we try one more. Okay, so over here, now what do we have over here? We have this sine of data is equal to x over 3. Therefore, data over here is equal to inverse sine of x over 3. Okay, so that's how it works. Okay, so just refresh your memory over here about the inverse sine. Okay. Any question about this? All right. Number 2. This integral over here, 1 over square root of x squared minus a squared, where a is a positive constant. Okay. Okay, so if we can get this one, we can actually use it as a formula in the future. Okay, so whenever we have 1 over square root of x squared minus a squared, when we integrate that, we can use it as a formula. Okay, so but how do we deal with this? So this one involves square root of x squared minus a squared. So that will make us think about using trig-sub. Okay, so what are you going to let x equal to? Now remember that I'm going to tell you that. Okay, so try to think about this x squared here as, okay, so we have a square over here minus the a squared here. Let's put this corresponding to the 1, okay, or 1 square, okay. And we want this to become a square over here, because that way, square root of a square, you can get rid of the square side, okay. Now, what do I put over here? Square that minus 1 equal to another quantity here square. What identity, what trig identity does this remind you? What should, fill in the blank. What should I put over here?
Is it the same one as secant
Secant
minus 1 is tangent?
Yeah, secant square minus 1
Square.
equal to tangent square, right? Okay, so over here is secant square beta minus 1 equal to tangent square beta, right? So when you have this, then you think about this, okay? So now, what do you think you're going to let x to be? X equal to what? Correspond to this secant beta, so that will equal to,
Secant.
yeah, you got it. So a times secant beta, okay? A times secant beta, okay. Data over here is in this. You don't need to remember this interval for this data. Okay, it's a convention of this. Okay, now if I do this trig-sub over here, what does this become? That was going to become a times what? What do I have on this side? Tangent data, right? So what do I put over here? A times
Tangent theta.
tangent data, a times tangent data. Okay, so if I do this trig-sub, okay. So over here we let x to be a times secant data, okay, and we're using trig-sub, okay. So what does dx equal to? Dx will be equal to,
Secant tangent
yes,
theta.
yes, we got it. Okay, so this is a times secant data, tangent data, right? Secant data, tangent data, and don't forget the d data, right? Because the derivative for secant is secant times tangent, right? Okay. Okay, now this is going to become this integral 1 over, what happened to this square root here? What does it become? Do you guys see over here? Square root of x squared minus a squared become what?
A
times
tangent
a
theta.
tangent data. Yes, you got it. Okay. So that will be a tangent data. Okay. And the dx over here, right? The dx over here is this part right here, this whole thing. This is the dx. Okay. So I put it down. So it's a secant data, tangent data, d data. Okay. All right. Now we can simplify this. Okay. So I'm going to divide out as a, divide out the tangent data. Hey, that looks much simpler now. So this is going to become the integral of secant data with respect to data. Right? Okay. Hey, do you guys remember the formula? What's the antiderivative of secant data? I think we went over that. We put it down last time. Do you guys remember? Anyone? Okay.
Is it secant? Never mind now.
Remember, secant and tangent are always related. Okay. So antiderivative secant has something to do with the secant and tangent. Okay. But this time is related this way. It's the ln of the absolute value of the sum of secant data and tangent data. Secant data and tangent data. Okay. And then finally adding a constant. Okay. We're still not done. Okay. We had to go back to x. Okay. So how do I go back to x? Anyone remember? We use the y triangle trick, right? This y triangle trick right here. Okay. So let's label this data. Okay. The trig-sub that we have used was what? X equal to, okay, I'm going to leave some space here. So we have x equal to a times secant data, right? That was the trig-sub that we used, which means that secant data is equal to x over a. Okay, so secant is the reciprocal cosine, right? So which means that cosine data is the reciprocal this, which is a over x. Cosine, it is what? Adjacent over hypotenuse, okay? Adjacent over hypotenuse. So over here, if I label the adjacent side here to be a, then the hypotenuse, we can label that by x. By the Pythagorean theorem, what will be this side here? Square root of so what do you have over here?
X squared minus a squared.
Square minus a squared, right? Okay. So that's the opposite side. So we got all three sides of this y triangle. So now we can deal with all of this, okay? So now we have this ln, and then this absolute value. Now secant, it is the reciprocal for cosine. So secant data will be hypotenuse over adjacent. So this will be, secant data here will be x over a. So x over a is this secant data over here. Okay. And then adding, tangent data is what? It's another trick here. I hope you can remember the trick. Okay.
Sine over cosine.
Yes, sine over cosine, but in terms of the side of the right triangle, tangent data will be opposite over adjacent. Okay, opposite over adjacent. So will be this over a. Okay. So over here you have this x squared minus a squared. So all this trick you need to. That's why I did the review in the beginning semester. Hopefully bring back the memory. Okay. Okay. So and press C. Okay. Now, if this is not in the test, then you're done. You can just leave like this. However, since we want to use it as a formula, so we can continue a little bit. Okay. So this one over here will be. We can take out this common. We can use this common denominator a. Okay. So that's a, and then you have this x plus this square root of x squared minus a squared, and then plus c. Now I'm going to ask you guys, do you guys remember ln of a quotient, right? for this quantity. Okay. When you take the ln of this quotient, that becomes the difference of the two ln, right? So this is ln of the absolute value of the quantity that is on top. So you get x plus this. And then subtracting ln of this quantity that is in the denominator, which is this a, and then plus c. All right. So remember, ln of a here is just a constant, okay? It's just a constant because a is a positive constant, okay? And the c here is any constant. So when you add these two together, or when you combine these two together, you just get another constant, okay? And let's call that constant over here, let's call that C1. Let's just call that C1. Then this will become ln of this part over here. And then adding C1. But C1 here is just any constant. Well, that's a lot of work, isn't it? Okay. So now we can use it as a formula. I'm not going to test you on this formula, okay? So the formula that we have over here is when you find anti-duality 1 over square root of x squared minus a squared, that will become ln of absolute value of this x plus this, and then adding a constant, C1 here, just any constant, arbitrary constant, okay? Wow, you guys did a good one, okay? That's really long, isn't it? Yeah. Wow, 12:06 already. Okay. The remaining part over here, I might just make a video. Any question before I end this? So, okay, if you guys have a question about homework, I can stay and answer your question, okay? Otherwise, I'm going to stop share over now. And, okay, and if you want to leave, you can say goodbye and leave. Okay, all right, so otherwise, if you have question, you can say.